Hi there. This is the third in a series of videos about how to deal with uncertainties when doing a physics report for IB. Now in this video we're going to take a look at how to graph things and what to do if your graph doesn't appear to be linear. Now if you remember from the previous videos, we have some data that's been made up here. We have times and distances. We've already found the average time and we've found the time squared. And what I want to do is I want to go ahead and figure out what does this graph look like? If I graph the distance divided by the time, what's that going to look like? So what I'll do is I'll go ahead and I'll just insert a graph. Now there's different ways you can do this in different products. I just do a simple scatter plot. And I'm going to select data. Now my data sources, I'm going to add a series of a set of points. My x values are going to be the times. Average times. I can't quite see them, but I think that'll get them. And my y values will be the distances. I think those are them right there. Okay. And if we graph these points, okay, they look, they sort of line up. Let's go ahead and try to put a trend line in here. If I put a trend line, they sort of fit. A little bit, not perfectly, but put a little trend line in there. I can look at the equation and all that mess if I want to, but I want to go ahead and see if this matches up, because maybe this wasn't quite what I'm expecting. Maybe I'm not expecting necessarily a linear fit. In fact, I want to see if there's maybe some kind of quadratic fit that's going to fit this data better. Now, my guess is that I'm going to have a graph that looks something like this. That has the equation y equals x to the n power. I don't know necessarily what that n power is right now, but I want to figure that out. So if I go down here and I look at the next, what I do is I take a log of both sides. Log base 10 of both sides. And what that'll allow us to do is to take this n value and move it out front. Now this makes things sort of nice, because now we have a straight line. We have y over here equals x multiplied by m. Here's our slope. Our slope is actually going to be that exponent. So I want to sort of figure out what does this graph look like. In this case, I don't have to worry so much about uncertainties. I'm going to delete this graph right now, by the way. I would include this on my actual report, but just for space, I'm going to delete it. I don't have to worry about uncertainties because we're just finding our n value right now. We'll go back later and we can figure out uncertainties when we make the actual graph. So I'm going to find the log of the distance and the log of the time. Of course, logarithm of the number does not have any units, so I'll just simply take log of, I'll select the distances over here. Okay, and so that's the log of the distances. You see we have some negative numbers, that's okay. We're going to take the log of the times. I'll do average time. And drag that down. And we have some numbers that look like gobbledygook right now, but let's go ahead and insert a chart, again a scatter plot, where I will select some data. I will make sure I can see my data here. I'll add a series. My x values are going to be log of time. And my y value is going to be the log of the distance. Okay. And I'll graph all that. And let's take the slope of that. Add the trend line. And we're going to format the trend line, display the equation. And it looks like the n value here is a 1.937. These numbers were actually worked out to be related by the square, so that does actually sort of work out. So I'm going to use this 1.937. Now, I'm just going to go ahead. The easy way to do this is hit equals slope. And we can just find the slope, known y's. Y value is log of the distance. And the known x's are the times. And here's the slope of that line. This is also something I put in my lab report, of course, with the axes labeled and all that. Due to space, I'm going to go ahead and erase this. So now I know that my equation, I originally took this equation right here. I graphed this on the y, this on the x. I found n, which was 1.973, which pretty close to 2. And that fits this equation right here. So what I'm going to do is I'm going to graph all my distances to equal x raised to the 1.93 power. So just to save some time, I'm just going to go ahead and pretend that's a 2. I'm going to pretend that's a square because we already have times squared values here. And I'm going to go ahead and graph, as you see here, my distance on the y-axis. And I'm going to graph my times squared on the x-axis. We're going to see what happens here. So I'm going to go ahead and make a graph, scatter plot. I'm going to select my data, add a series. Again, we get cluttered quickly here. For the x values, I'll do times squared. Those are those values there. And I'll go ahead on my y values and pick the distance. Select those. And OK. And that looks pretty good. That's if I add the trend line to this line. You can actually see the equation there. This trend line looks pretty nice. And what I like about this trend line is that I know that if I allowed 0 time for something to happen, it's probably going to move a distance to 0. I'd expect this trend line to hit at the origin. And as you can see here, it does seem to hit fairly close to the origin. So I've got my data points. Everything's looking pretty good right now. Of course, I can go in and I can add some art. I can talk about how, I can add the axes, labels, and all that. I have distance on the y times squared on the x. What I want to do here is I want to go ahead and add my error bars. I want to add the error bars to these points. So I'll go and find error bars. You're going to have to find error bars. They're not always obvious where they are. And go ahead and just select one of these. It's going to add some crazy lines in there, which we're not so worried about. I'm going to click on the horizontal. Horizontal is times squared. I know my uncertainty for times squared is 0.02. So let me right click, format error bars. We're going to add a fixed value of 0.02. And hit OK. As we can see, that's a decent uncertainty. On the y-axis, the distance, my uncertainty is 0.01. So we'll format this. I'm guessing this is going to be much less. 0.01 is a fixed value. Hit OK. And yeah, they've basically disappeared. I cannot see those uncertainties anymore. So now I have my, IB only asks for uncertainties for one axis. In this case, it is my time that is the very uncertain axis. Of course, in your evaluation, you want to talk about why your time was so uncertain. You'd want to certainly mention that, but for now, we're just going to go ahead and leave it as is with our error bars. What we've done is we've gone ahead, we took our distance and our time values, we found the relationship between them. The relationship between them seems to be where the distance equals time raised to the 1.94. We cheated and just used 2. And we went ahead and found the length of the error bars. In the next video, we're going to go ahead and find the min and max slopes and talk about what that means. Talk about some of the importance of those min and max slopes and how you'd write about that in a paper.